Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes.
All right, ladies and gentlemen, we're here to talk a little bit about observations, inferences, classifying. And when we're making observations, we're going to use our 5 senses, our ears, our nose, not usually our mouth in science because it can be a little bit dangerous, but you do get information that way, touching, and of course, smelling. So when you make observations, what you're doing is you're collecting information, and that is information that most people would agree with. Observations aren't something that there's a lot of conjecture with or that you can argue about. Inferences, on the other hand, there is some argument about those. Sounds plausible because what you do to make an inference is make an observation, use some prior knowledge, some experiences that you've had, and then come up with an idea. So, for example, I could observe that it's sunny outside and therefore determine that maybe it's warm because in the past when it's sunny, it's been warm. So once we make observations, we want to organize that information somehow, and the way scientists do that is to classify things. They put things together of similar types. So right down there you can see a little picture of a rock classification chart that is in your earth science reference tables, and those are classified by how they form into 3 types of rocks, either sedimentary, igneous, or metamorphic, and you'll see those in the little square boxes on the chart. So take a look at that. Some other things that are in the reference tables that are classified: stars are classified based on how bright or luminous they are and their size. So, there's a lot of things that scientists are classifying out there. Why? Because it helps us to make sense of the world. Now, when we classify things or when we're collecting information, we want to describe them. And one of the things we describe is the mass of the object. And mass is simply a measure of how many molecules are in that object. So if you look, we've got a couple elephants there, a big elephant and a little baby elephant. Which do you think has more molecules in it? My guess is going to be the bigger of the 2 elephants. That's just my experience. But there's a way we can actually measure that, and that is by finding out what the object's mass is. You don't want to confuse mass with weight. Mass is how many molecules there are. Weight has to do with gravity. We'll get into that later in the year. But there's 2 ways you can figure out the mass of an object, either using a triple beam balance, which you might be familiar with, or an electronic balance, which we'll use this year. So if we heat an object up, is it going to change the mass? What do you think? Of course it's not going to change the mass because it's still the same object. There's still the same number of molecules. It's just hotter now. So that's the deal with that. What about if we send something to the moon? Is that going to change the object's mass? No, it's not. Because again, it's still got the same number of molecules, ladies and gentlemen. Another property we might want to find out is about an object's volume. Now there's 2 types of volume. Regular. These are objects that are squares or cubes. They have a regular shape. You probably learned about them in geometry if you've studied that in math. And the most famous type of volume that we measure is using the length times width times height equation for regular objects. But that's not always the case. Sometimes objects have irregular volumes like a rock, or those elephants we were talking about. So how do we figure out their volume? Well, of course, then we need a graduated cylinder. There's a problem up there now that you can look at, asking how you would do that out. So press pause for a moment and see if you can remember from 7th grade how to find the volume of an irregular object. Well, welcome back, ladies and gentlemen. Of course, to find the volume of an irregular object, you'd use a graduated cylinder and go through the steps that are listed. You might want to make note of those if you had a little bit of trouble remembering, so that's out there for you. Now, The last thing we want to talk about is why we are finding the volume and mass of objects. Frequently, we do this to figure out the density of the molecules in the object. So if you look at my little map down there, you can see that the little blips of light, which is the cities at night, give off light. And we took a picture from space. This is what it looks like. That there are some spots where there's a lot of dots close together, and then there's other areas like up in the northwest of the United States and up as we go towards north of the map into Canada, that the dots are very spaced out and there's a lot of darkness. So where there's a lot of light, we'd say there's a high density of light. And when there's not so much light, some black, we'd say there's a low density. Of course, with this again, you need to remember that when you heat an object up, the molecules are literally going to get farther apart. You know, when you are very warm, you probably don't want to be curled up in a little ball because it makes you feel warmer. However, if you're really warm, or if you're really cold, you might, start to shiver like this or curl up in a little ball under a blanket. That's because you're cold. Molecules do the same thing. When they get warmed up, the molecules spread out and the density goes down. When molecules cool off, the molecules come together. When a substance cools off, its molecules will come together, sending the density up because there'll be more molecules in a space. So I've got a couple problems for you to figure out. We'll let you work through those, and then we'll do a little talking. One of the relationships you need to know about, ladies and gentlemen, is the relationship between density and temperature. So as you look, you'll notice that when temperature is low, close to the y-axis, density is really high. And that as temperature goes up, density goes down. So that's when we talked about that expanding and contracting thing, That's why that is, ladies and gentlemen. So now it's time for you to practice some density, and I've got a few problems there for you to give a look through. So give them a try, see how they are. I'll have the answers up at the end of this video so you can check your work. Well, ladies and gentlemen, thanks for watching through that video. Hopefully you tried the problems. If you had any questions or problems, please send me a WITS mail. Let me know. Thanks for checking things out. See you soon.